In problem 17, we're told that the function given represents the value of a comic book T years after its purchase. They want to know what the yearly rate of appreciation is. Well, we're given a function, but we need to know what appreciation means. Appreciation is an increase in monetary value, and so they're looking for the rate of increase in the value of the comic book. The rate of increase is given by the multiplier, 1.017. That's 1 plus 0.017. In other words, every year we have 100% of the comic book's value plus 1.7% more. Each year, the comic book is going up by a rate of 1.7%, and so the rate of appreciation is 1.7%. Choice 2. In exercise 18, we're told that Sam is solving a quadratic equation by completing the square. We're given one of the equations that he came up with, x minus 5/2 squared equals 13/4. Which of these equations could have been his original equation? There's a couple of options as to how we could solve this problem. The first option would be to take each of the choices and complete the square. The leading coefficient is 1, and so we simply take half of the b term, 5/2, square it, 25/4, and add it to both sides of the equation. Now, take a look and see which equation matches Sam's. When we look carefully, we see that choice 4 is the one that gives us Sam's equation, and so choice 4 is the answer. If you don't want to go through the trouble of completing the square on all 4 of these equations, you do have another choice. You could take each of the equations and set it equal to 0. Replace the 0 with y equals, and then put it into your graphing calculator and look at the table of values. The equations that are equivalent will have identical tables. Look at each of the choices. They're all equal to 0, so we'll set them y equals, and we'll generate the table. Examine the tables carefully. Which one matches the original? The table for choice 4. And so choice 4 must be the equivalent equation, and therefore it's the original equation that Sam started with. In exercise 19, we're told that the distance a free-falling object has traveled can be modeled by the equation d equals 1/2 at squared. We want to solve for t in terms of a and d. Notice that we have a fraction of 1/2. Let's begin by clearing the fraction by multiplying the equation by 2. 2d equals at squared. Now we want to isolate t, so we divide by a. Finally, we have t squared alone on the right-hand side. The inverse of squaring is taking the square root, and so t equals positive or negative square root of 2d over a. Look at the choices carefully. Which one matches our answer? Choice 2. In exercise 20, we have a table that shows the annual salary for 24 members of a professional sports team. The team signs an additional player to a contract worth $10 million. What happens to the mean and the median? Begin by taking the data and putting it in a list and spreadsheet. Add a calculator and perform your one-variable statistics. Notice we see that the mean is 2.56 and the median is 1.4. Now, let's go back into the list and spreadsheet and let's add an additional value, 10, to represent the $10 million contract. Perform the one-variable statistics on the new data table, and you'll see that the mean is now 2.86 and the median is 1.4. Now, let's compare these numbers and let's see which choice is our best answer. The original mean was 2.56 and the new mean is 2.86, so the mean increased. The original median was 1.4 and the new median is also 1.4. The median did not change. Read the choices carefully. Choice 3. Only the mean will increase is the correct answer. In exercise 21, we're given an equation to solve, and they give us the first couple of steps that the student performed. They want to know what the next correct step is. Let's write out the equation, and let's work through solving it so that we can find the next correct step. The first step was to add 17 to both sides, and that gave us the 4 times 3x minus 1 squared equals 100. The next step would be to divide by 4, and you'll see we have the 3x minus 1 squared equals 25. What's the next step? Notice we have a binomial squared isolated on the left-hand side. The inverse of squaring is to take the square root, and so we take the square root of both sides. Don't forget the plus and minus in front of the square root of 25. That leaves us with 3x minus 1 equals positive and negative 5. Choice 1 is our answer. In exercise 22, we're given a pattern of blocks, and we're asked which of the three formulas could be used to determine the number of blocks in the nth term. Let's begin by identifying the pattern. The first one has 2, the second has 6, the third has 10, and the fourth has 14. Which of these equations would create that sequence, 2, 6, 10, 14? Equation 1 is a simple explicit equation. We can put that in our graphing calculator as y equals x plus 4. Look at the table. That equation, the first term generated is 5, the second 6, the third 7, and the fourth 8. That's not the correct sequence, and so equation 1 cannot generate the sequence that we want. It's not a correct solution. Let's look at the third equation. That's also an explicit formula. We can put that in our calculator as y equals 4x minus 2. When we do that, we see the first term is 2, the second is 6, the third is 10, the fourth is 14. That matches our sequence, so equation number 3 is a valid equation. How about equation number 2? That's a recursive formula. an equals an minus 1 plus 4. The first term is 2, and each term is generated by taking the previous term and adding 4 to it. When I do that, I get the sequence 2, 6, 10, and 14. Again, that matches the sequence that I have from the blocks. So it looks like equations 2 and 3 are valid equations for my sequence. Read the choices carefully. Which one gives us equation 2 and equation 3? Choice 3. In exercise 23, we're given an equation x squared minus 8x equals 24. We want to solve the equation, and there's a few ways we could do this. One possible way is to set the equation equal to 0 and then write the equation in vertex form by completing the square. The leading coefficient is already 1, so we simply need to take half of the middle term, negative 8, and square half of that value, negative 4 squared, is 16. 16 is the value that goes into the boxes. Now we can write it in vertex form. Now let's solve the equation. Add 40 to both sides. We now have x minus 4 squared isolated, so we'll take the square root of both sides, and then add 4. X is 4 plus or minus the square root of 40. The square root of 40 can be simplified to 2 square roots of 10, and so the solution to this equation is x equals 4 plus or minus 2 square roots of 10. Choice 1. Another possibility would be to use the quadratic formula. Set the equation equal to 0, identify your a, b, and c value, and then substitute those values into the quadratic formula. Evaluate the radicand, simplify the radical, and then distribute the division. X equals 4 plus or minus 2 square roots of 10. And so once again, choice 1 is the answer. In exercise 24, Natasha is planning a school celebration. She wants to have live music and food for everyone who attends. She found that a band will charge her $750, and a caterer who will provide snacks and drinks will charge $2.25 per person. She wants to keep the average cost per person between $2.75 and $3.25. How many people must attend for this goal to be met? Let's summarize the information that we have. A band costs $750. That's a fixed cost. The caterer charges $2.25 per person. That's a variable cost. $2.25 times P, the number of people who attend. She wants the cost per person to be between $2.75 and $3.25. Again, this is a cost per person, so we can represent it by 2.75p and 3.25p. Remember that the cost per person is going to be between $2.75 and $3.25. We can write that as a single inequality as shown on the screen. Now, let's see if we can write our inequality. we want the cost to be between $275 per person and $325 per person. The cost is generated by the band, $750, plus the cost of catering, $2.25 per person. Now that we have our inequality written, we can actually go ahead and solve it. This is a compound inequality connected by the word and. The first inequality can be found on the left-hand side. We write it down, and then we'll solve it. The second inequality can be found on the right-hand side. Again, we'll write that down, and then we'll solve that one separately. Solve each of the inequalities step by step to get your values. The first inequality says P is less than 1,500. She must have fewer than 1,500 people. The second inequality, we solve that one, and we find that P is greater than 750. In this case, we find that she must have more than 750 people. And so her answer is P is greater than 750 and P is less than 1,500. We can write that as a single inequality. P is between 750 and 1,500. Choice 4.